Hey guys, what's up? Welcome back to today's video. I hope you watched the previous video of mine and you have got some background knowledge about why bonding takes place, right? So yes, you're right. I'm there on the chapter Chemical Bonding, and today we will study the details about the Cossel-Lewis theory. I hope you would have watched the previous recordings because we have done the minute discussions about what was told by Lewis. So today I will be starting with the Lewis dot structure. So from today's video, you will be getting at least 2 marks question in any of your unit tests, in any of your term papers, in your half yearlies, finals. You will be getting at least 2 mark question from today's video for sure. So do watch it very carefully, take a pen, a notebook and try to practice what I'm trying to teach you. Okay? So you remember I told you that according to this person Lewis, he said that atom will be considered in 2 parts. One will be the positively charged kernels plus the valence electrons will be there. We will just be talking about valence electrons. All the other electrons will be deeply seated close to the nucleus, right? Like for example, I'm talking about sodium, then it is 2, 8, 1. Only these valence electrons are the ones which are exposed to the outside environment, which are exposed to the outside atmosphere, which can come in contact with other atoms. But if I talk about 2 and 8 electrons, they are very close to nucleus. They are kind of inert. They will not react with any other atom. Okay, so our main focus today will be only on these valence electrons. Understood? So now let me tell you, according to Lewis, he proposed some structures which we can easily draw for atoms. Like, you just have to take into account valence electrons of all the atoms. Let me start with first of all hydrogen. It has just 1 electron. So you represent it H dot. So that is why Lewis dot structure you represent in the terms of dots. Then we have helium. So hydrogen is 1 only, helium is 2. So either you can represent helium like this, or it's up to you, you can also represent helium like this. But we generally prefer paired electrons in the case of helium. So we write it like this. But it's up to you, whichever way you want, you can go that way. Okay. Moving on to the next element, which is lithium. Lithium is 3, which is 2, 1. We are not concerned about 2. We are just concerned about 1 electrons. So this is the Lewis dot structure for lithium. Moving on to beryllium. Beryllium is 2, 2. Take care of these 2 electrons. So you represent it like this, or you represent it like this. Okay. Now moving further to, after beryllium we have boron, which is 2, 3. I will write it 1, 2, 3. You can also pair them up, but the better thing is to keep them unpaired until and unless they have not attained a complete octet or a complete duplet. In case of helium, duplet is complete, so I write it like this rather than writing it like this and this. Understood? But for beryllium, octet is not complete, duplet is not complete. Beryllium can have more electrons. So rather than writing like this, I will write it like this. Okay? Moving on to, so 5 are done. Let us move on to the next element, which is carbon, which is 2, 4. So I'll represent it as 1, 2, 3, 4. Or whenever required, we will also represent it as 1, 2, 3, 4. Whichever way you want to place the electrons, it's up to you. Okay. Then moving on to nitrogen, 2, 5. We write N, 1, 2, 3, 4, 5. You can write it this way. This is acceptable. Then moving on to oxygen, 2, 6. We will consider only 6 electrons. 1, 2, 3, 4, 5, 6. Sometimes this is okay. Sometimes we need 1, 2, 3, 4, 5, 6. So based upon the questions, we will change the way we want to write. Otherwise, every structure is acceptable. Similarly, if I move on to fluorine, 1, 2, 3, 4, 5, 6, 7, only one possibility. Then if we move to neon, 1, 2, 3, 4, 5, 6, 7, 8. This is the one where octet is complete. Understood? So now let us see, after doing the Lewis dot structures, how the atoms can combine with each other to form molecule. Now I have written so many examples here and I will try to discuss all these examples one by one in details. Let us first begin with H2 molecule. How it is formed? Hydrogen is with one electron. Another hydrogen is there with one electron. Just represent the Lewis dot structures for each hydrogen. Now this combines with this and duplet is complete. This combines with this, duplet is complete. It led to the formation of H and then you put 2 electrons on this line. So this line which I have drawn is known as a covalent bond. I hope now you can understand that there is no such line joining the atoms. It's just force of attraction which holds the two atoms together. Understood? And since it is formed by 2 electrons, one line represents 2 electrons. So this is known as single bond. A single bond is basically formed by the combination of 2 electrons. Understood? So this was about how hydrogen now has 2 electrons. This hydrogen is also having 2 electrons. Done. That's it. Now let us move on to the another molecule. And the molecule I have chosen, so this is done. Now the molecule I have chosen is chlorine. Let's see. Question number 1. What to do? Draw the Lewis dot structures. Cl, Cl. 1, 2, 3, 4, 5, 6, 7. Okay. Now it's your wish. If you want to draw the dots, you can draw dots. If you want to draw these asterisk symbols, that's also acceptable. Whichever way you feel easy, you can go with that way. Okay. So chlorine has 7. It says that, oops, I need 1 more electron. Similarly, this has 7. It says I need 1 more. So this chlorine takes 1 electron from this chlorine. So now it has 7 plus 1, 8. Octet complete. Now this chlorine will further take 1 electron from this chlorine and will now have 8 electrons. So again octet complete, and hence we say Cl, Cl will form a bond with each other. And again the bond will be formed by combination of 2 electrons, so single bond. Now these 2 electrons which are used in bonding are known as bond pair of electrons, which in short we write BP. BP means the pair of electron which is used for bonding. But you see 1, 2, 3, 4, 5, 6. These electrons and 1, 2, 3, 4, 5, 6. These electrons which are not used in bonding, which are left alone, these are said to be lone pair of electrons, which we call as LP. Understood? So Cl2 is also formed by joining 2 electrons, and hence we are done with the structure of Cl2. Let us now try to complicate the questions and let us move on to the structure of water. Now question number 1 which arises, which atom should be there in the center? Now in this case, oxygen is bigger than hydrogen. So hydrogen, 2 hydrogens can easily settle down onto oxygen, right? Whereas 1 hydrogen cannot have 2 oxygens. So the one which is bigger will be said to be the central atom. The one which is big in size, or you can say the one with more number of valence electrons will be, this is the main condition, will be the central atom. Hydrogen has 1 valence electron. Each oxygen has 6 valence electrons. So basically we will go for oxygen as the central atom. Now how to do? Put 1 oxygen. Now we have 1, 2, 3, 4, 5, 6. Oxygen needs 2 more, and each hydrogen comes with 1 electron, right? So now think. Oxygen needs 2 more and each hydrogen needs 1 more. So rather than hydrogen combining with hydrogen, each hydrogen says, why not I should take 1 electron from oxygen? Even this will take 1 electron from oxygen. So this combines here, this combines here. So each hydrogen's duplet is complete. Look at oxygen. 1, 2, 3, 4, 5, 6. It takes one from hydrogen and one from this hydrogen. So this becomes a little complicated. So what we do, we draw them like this. So now you do not need to draw these circles, these dabbas. No man, not required. You just join these. So 1, 2 and 1, 2. Now count for hydrogen. 1, 2. Hydrogen is stable. Duplet complete. Count for this hydrogen. 1, 2. Duplet complete. Count for oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Octet complete. Happy molecule. Understood? So this was how we can draw the structure of water. Now let us move on to the next molecule. You have already done all these molecules in grade 10th. So I think you should know them. But if you do not know them, then such molecules I'm talking with you. So let us now move to the next molecule. So if I move on to the next molecule, we have CCl4. I am not going to draw the circles. It becomes really complicated. It becomes messy. No one will ask you to draw the circles in exam. It's just for your understanding, okay? So carbon has 4. 1, 2, 3, 4. And each chlorine has 7. So each chlorine needs one more electron. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Done? So take one from here, chlorine becomes happy. Take one from here, chlorine becomes happy. One from here, happy. One from here, happy. Now look at carbon. Each carbon is having 1, 2, 3, 4, 5, 6, 7, 8. So the entire molecule becomes super happy. Understood? So this was the structure of CCl4. Now let us move on to next structure, which is C2H6. Now you have to take a pause and think. There are 2 carbons and there are 6 hydrogens. So can I divide the molecule symmetrically? Can I cut it down and say this is kind of CH3 twice? So 2 such molecules of CH3 are there, right? So see how we will write. Let us first draw one CH3 unit. So C, 1, 2, 3, 4. Another CH3 I'll draw. C, 1, 2, 3, 4. 2 carbons you draw. Give 3 hydrogens to this. Give 3 hydrogens to this. Just divide it symmetrically. 1, 2, 3. 3 hydrogens done. Now 1, 2, 3. Done. 3 hydrogens done. Now this hydrogen takes one. Duplet complete. Duplet complete. Duplet complete. So CH3 is kind of stable now. Duplet complete. Duplet complete. Duplet complete. All hydrogens are happy. Now take care about carbon. Carbon is 1, 2, 3, 4, 5, 6, 7. Oops, this carbon has one less electron. 1, 2, 3, 4, 5, 6, 7. It has one less electron. So both of them are having one electron which they need. So don't you think they'll combine with each other? So this becomes C2H6. That's it. And how do we write it more nicely? I will just write it as C single bond. C, 3 hydrogens here and 3 hydrogens here. If you would have done this in grade 10th, you should know the name, which is ethane. Done? So this was the structure C2H6. We studied all the single bond compounds. Now let us take the example of carbon dioxide. Carbon is just 1, so it should be the central atom. Oxygens are 2. So we don't consider oxygen as central atom. We will consider carbon as central atom here. Generally, whichever is 1 should be considered as central atom. Now each carbon, 1 oxygen, 1 oxygen. Carbon has how many? 4. So I'll write 1, 2, 3, 4. Each oxygen has 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oxygen needs 2 more. So instead of writing these 2 carbons like this, it says here, please give 2 to me, no? Now see, oxygen has 6 earlier and 2 now. So oxygen become duplet complete, octet complete and happy. The same goes here. See, oxygen became happy. Now count for carbon. 1, 2, 3, 4, 5, 6, 7, 8. Even our carbon becomes happy, and this is the structure of carbon dioxide. Okay. Now here if you see, this bond consists of 2 electrons. This bond also consists of 2 electrons. So the total electrons which are being shared between C and O on one side are 4. And 2 such bonds are formed. So we call this as double bond. So now you should remember how to draw the structure of carbon dioxide. It is C double bond O, C double bond O. Understood? So this was about carbon dioxide. Done. Let us now move to another structure, which is ammonia. Anywhere you are getting doubts, please do let me know. Now ammonia is the central atom because it is a single atom. So I'll write it this. 1, 2, 3, 4, 5. 3 hydrogens. 1, 2, 3. Understood? Hydrogen needs 1, happy, 1, happy, 1, happy. How many are there with nitrogen? 1, 2, 3, 4, 5, 6, 7, 8. Woo, nitrogen also became happy. So this is the structure of ammonia. I hope this much is clear. Now let us move on to the structure of N2. So I'll be going from simpler to the higher levels. So N2 we are doing nitrogen. So both of them are nitrogen. So there is no central atom in this case. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now nitrogen says that here I have 5, I need 3 more. So rather than me representing this here, can't I represent this here? Similarly this rather than here, I can represent it here. So 5, 6, 7, 8. This 5 combined with these 3. Similarly these 5 combined with these 3. And this leads to the formation of N triple bond N. Understood? So here 1, 2, 3, 4, 5, 6. 6 electrons are being shared. So this kind of bond is known as a triple bond. Now rather than representing these 2 electrons separately, I will combine them and say that they are present together. Nothing like this was told to us by Lewis, but I am telling you, maybe in later videos you will realize why I combined these 2 electrons and I kept them together. And this is what is termed as lone pair of electrons. Done? So this is also done. Now let us move to C2H4. C2H4. Just we do the same way when we did C2H6. So just simplify it. Can't I say CH2 twice? That each carbon gets 2 hydrogens. So let us write each carbon 1, 2, 3, 4. Why did I represent 2 dots here? Because I have 2 hydrogens. And other dots I will represent like this. So 1, 2, 3, 4. This hydrogen, this hydrogen. Hydrogen combine, happy, happy. All 4 hydrogens are happy. Done? Now look at carbon. 1, 2, 3, 4, 5, 6. It needs 2 more. 1, 2, 3, 4, 5, 6. It needs 2 more. So finally these 2 will combine, leading to the formation of double bond. And this is what is known as ethene. Okay, so final structure I'll draw it like this. It's up to you. You want to draw 2 hydrogens upside, that's okay. If you want to draw like this, everything is acceptable. Understood? So this is C2H4. Now let us do another molecule, C2H2. So if you find all these examples simple, you can move further to the video and we can do these examples, carbonate and all. Otherwise, I will recommend you to keep on watching because your concepts will become really clear. So simplify it. It is CH twice. Each carbon, 1 hydrogen. If you want to write it like this, let's say, this is also okay, but I love symmetry, nature loves symmetry, so we write it like this. So 1, 1. Each carbon, 1, 2, 3, 4. 1, okay. So 1, 2, 3, 4. Hydrogen happy, hydrogen happy. Understood? So now carbon. It has 1, 2, 3, 4, 5. It needs 3 more. So it took these 3 more from here. And that is what is a triple bond formation. The molecule is termed as ethyne and we simply write it as HC triple bond CH. Done? So this was about the molecule C2H2. Now we have kind of complicated questions. And first I will be starting with carbonate ion, which is CO3 whole bracket 2 minus. Take a break and listen very carefully. Only one carbon is there, so carbon will be in the center. And 3 oxygens are there. You represent whichever way you want, like this. Understood? Now, if there are 2 negative ions, like 2 charges are there, 2 minuses there, that means we have 2 extra electrons. So, negative means extra electrons are there. So, 2 negative means 2 extra electrons. And who will get extra electrons? Obviously, the electronegative element. Electronegative element will get extra electrons. And out of carbon and oxygen, which is electronegative? Oxygen, right? So, each oxygen was having 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let me draw like this. Each oxygen was having 6, 6, 6. Now, carbon was having 1, 2, 3, 4 electrons. Now, I told you there are 2 negative. 2 negative means 2 extra electrons. So, each oxygen will get 1 extra electron. So, oxygen was 6, it was O. When you give 1 extra electron, it becomes O minus. Understood? Oxygen was 6, it was O. But it got 1 extra minus, so it becomes O minus. Fine. Now, it has 1, 2, 3, 4, 5, 6, 7. It needs 1 more. It takes from this carbon. Octet complete. 1, 2, 3, 4, 5, 6, 7. It takes 1 from this carbon and octet complete. Now, if I talk about this oxygen, it has 1, 2, 3, 4, 5, 6. It needs 2 more. Carbon has 1, 2, 3, 4, 5, 6. It needs 2 more. So, both of them will form a double bond, and hence you can draw this as the Lewis dot structure for carbonate ion. I hope this much is clear. Let us move further. So, carbonate is done. Let us move to the same concept we will be using in the case of NO2 minus. Which element is only one? Nitrogen. So, it should be in the center. Put one O, put one O. 2 oxygens, you can keep here, 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 whichever way you want. Okay. Now, let us put the electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oxygen 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Done. Now there is 1 minus, and which is electronegative? Oxygen. So 1 electron goes to oxygen, it gets minus. Oxygen has 6 plus 1, 7. It needs 1 more. Oxygen became happy. Done. Now let us look at this oxygen 1, 2, 3, 4, 5, 6. It needs 2 more. So it will take 2 from nitrogen. It became happy. Now let us count for nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Woo man, nice. Even nitrogen became happy. So this is how we draw the structure of NO2 minus, which is nitrite ion. Done. Let us now talk about CO. So we have carbon. None of them is central atom because only 2 atoms are there. So no central, no side atom. So 1, 2, 3, 4, 5, 6. Okay. Before I do the structure of CO, let me first do the structure of nitric acid, which is HNO3. Now, oxygen cannot be the central atom because 3 oxygens are here. So, let us, even hydrogen is very small, cannot be the central atom. Let us say nitrogen is the central atom. So, draw like this. 1, 2, 3, 4, 5. Done? Let us represent 3 oxygens. Now, 1 hydrogen is there. You might be thinking, ma'am, why can't I represent it like this? Now, see, if hydrogen and oxygen are there in the structure, OH bond will be formed. They always love to form OH bond. So let me represent hydrogen somewhere here. Hydrogen has 1 electron, oxygen 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Done? Now see, hydrogen needs 1 more. So it asks oxygen, yeah, can you give me 1 more electron? Oxygen says, okay, take it. Hydrogen became happy. Now oxygen is 1, 2, 3, 4, 5, 6, 7. It takes 1 from nitrogen. It becomes 8. Oxygen became happy. Done. Now let us talk about nitrogen. It had 1, 2, 3, 4, 5, 6. It is having just 6 electrons. It needs 2 more. And this oxygen also needs 2 more. Oxygen became happy, nitrogen became happy. That's it. Now the question rises, ma'am, why are we taking in account this oxygen? This is not even required. Why did you take this oxygen? Because nitrogen's octet is complete, oxygen's octet is complete, this is complete, this is complete. Why do we need this oxygen? Now do you remember that relationship, one-sided love? Nitrogen has these 2 extra electrons, right? It is having extra electrons even though the octet is complete, but still those 2 electrons are extra. And oxygen is saying, yeah, I need 2 more. Anyhow the other you give 2 more. So this nitrogen says, yeah, okay, don't worry. I'm already in love with you. You are already there with me. So let me give my 2 electrons to you by forming a coordinate bond. Understood? So nitrogen was having 2 extra electrons, so it gave those 2 extra electrons to oxygen, leading to the formation of coordinate bond. Done? So if I simply ask you to draw the structure, the simplest structure will be N double bond O, OH, 2 electrons given to oxygen. So this is the structure of nitric acid, where for the first time I introduced the concept of coordinate bond formation. I hope you understood this, right? So this is done. Let us move on to another molecule, which is ozone O3. Let's see how this is to be done. Let us first do O2, how O2 exists. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, each oxygen needs 2 electrons. So this and this combine together. O2 is done. Now let us look at another oxygen. 1, 2, 3, 4, 5, 6. This oxygen has a complete octet. This has a complete octet. Why the hell they are going to combine with another oxygen? They should not, right? But take a break. This oxygen said, yeah, I need 2 more. If anyone can give me 2 more, I'll be like very happy. So this oxygen says, yeah, my octet is complete, so you don't worry. I will give you these 2 electrons to you, again forming a coordinate bond. And hence, there is another coordinate bond which we are going to discuss here, which is in ozone O3. So there is a coordinate bond being formed. Done? So this is also clear. Now let us move on to the last molecule, which is carbon monoxide. Carbon 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Done? Now carbon needs, carbon is 1, 2, 3, 4, sorry. So carbon needs 4 more, but oxygen needs 2 more. So oxygen says, let me combine. Once oxygen has combined to form 1, 2, 3, 4, 5, 6, 7, 8 electrons, oxygen got an octet complete. It was like really happy. Now, if you look at carbon, it has 1, 2, 3, 4, 5, 6 only. It still needs 2 more electrons. Is there any other atom which can give 2 electrons to carbon? No, nothing is there. So now oxygen comes forward and says, don't worry man, I am in love with you, so I will give you my 2 electrons. That's it. So this is another coordinate bond being formed in this structure. Okay, so if I ask you to draw carbon monoxide, it is something like, so this is another coordinate bonded structure. Done? So guys, this was all about the different molecules which are there in NCERT which can be asked in your exam. I have tried to draw the Lewis dot structures for all of them. Now the only thing you need to do is to practice all these structures. Okay, so I have written these few molecules, but their structure I will be taking in the next video because that will be related to the problems with Lewis dot structures. Okay, so do revise whatever I have taught you and I'll meet you very soon. Bye-bye.